Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhamad Nazirul Akmal bin Said. My metric number is B0717108994. Okay, today I would like to present about the lab one, which is the kinematic viscosity. Okay, as we know that the viscosity is defined as the resistance to flow of a fluid deformed by a shear stress. Okay, next, viscosity is the most crucial part in the lubrication. It shows the strength of the oil film between surface. The fluid internal resistance to flow and may be thought of as a measure of fluid friction. Okay, in this Kinematic lab, either increase or decrease as a result of lubricant regulation, contamination, fluidization, and shear tightening. Okay, in this lab, we also can determine by measuring the force required to overcome fluid friction in the film of non as dimension.
Hi, Assalamualaikum. My name is Muhamad Zhafiran bin Razalli. Metric number B0171705552. So today I would like to present about objective for this lab 1, which is kinematic viscosity. In this lab 1, it have 3 objectives for this lab. So the first one is to understand kinematic viscosity measurement method. Second, to determine viscosity index of lubricant sample. And lastly, to understand grade of lubricant oil based on the viscosity. So that's all for objective for lab 1. So next, I will pass to Syabil to give more information for methodology, which is procedure. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syabil bin Basri. My metric number is B0717102007. Okay, today I would like to tell about the methodology or procedure for kinematic viscosity experiment. Okay, first of all, set up all the things that you need to do. Okay, first, hold the viscometer, pull out the sliding plug, ensure the viscometer tube and steel bar are clean. Okay, prepare and educate the oil sample. Okay, next, hold the viscometer vertically, select bleed valve, then pull out the sliding plug. Okay, you need to fill the tube with the oil sample to just above the V plate. Okay, slowly push in and rotate the plug with the bar open. Let the oil bleed until the air is expelled. Okay, tighten the bleed valve fully. Wipe off excess oil from the plug. Next, plate viscometer back on its base and connect the power cable. Okay, before you start, you need to turn on the main power and turn on the power supply. Okay, using the switch next to the socket. Okay, next, select mode 1. Use speed and arrow key to input the oil density. Okay, next is select mode 5 and press return to save the new oil density. Okay, you need to select the temperature to 40 degrees C and confirm with the return key. Temperature display flashes as a viscometer hits the oil. Okay, then the oil temperature is stable. The display will show the viscosity of 40 degrees C as selected. Okay, next you need to tilt viscometer when prompt. Wait until the temperature is stable. Okay, when it reaches to 40 degrees C, it means stable temperature. Okay, use up the arrow key to toggle display of viscosity from 40 degrees C to 100 degrees C. Okay, next use down the arrow key to toggle display of viscosity 100 degrees C to 40 degrees C. Okay, next repeat the tilting process until the next reading. Okay, turn off the main power. After you finish everything, you need to turn off the main power. Disconnect the yellow power supply lead. Slowly pull up and rotate the plug. Carefully remove the oil sample into the beaker so that the steel ball do not fall out. Okay, remember, clean up the viscometer tube and the steel ball. And After finish, put back the steel ball inside the viscometer tube. After you finish, you need to put back the steel ball inside the viscometer. After finish everything, you need to do as a usual thing, clean up the workstation, okay, by using a solvent such as the acetone. That's the procedure and the methodology. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Zahidi, BMMM Hamzah. I'm here to explain on the discussion for kinematic viscosity lab 1. The question that have been given to us is why viscosity of new and used oil change or might not be changed. This is because the force enhancer can pull down or break apart during oil use, leading the oil viscosity to decrease. Synthetic oil might last longer, but you need to adjust them periodically to provide the best possible protection for your engine. The second question is the explanation to the effect of water contamination on circulation of lubricant oil. The answer is the contamination of the water has a detrimental effect on the lubricant's base oil, leading to issues such as oxidation, hydrolysis, and aeration. Water induces changes in the chemical and physical property of mineral oils and certain synthetic in oxidation and hydrolysis, causing acid forming, varnish, and sludge. The third question is the factor that cause the changes of lubricant viscosity. The first one is oxidation, the second one is thermal degradation, the fourth one is contamination, the fifth one is air release, and the last one is demulsibility. The last question for this discussion is the effect of the changes of lubricant viscosity. Single most significant performance property is viscosity. If the lubricant is too thick, it flows slower, causing further friction and therefore having a negative effect on the equipment performance. Thank you, and that's all from us.